Okay, voices off, guys. So, we have these four parts that we learned about. These four parts, these 4 points of concurrency. First of all, what's a point of concurrency? What did point of concurrency mean? Where 3 or more lines meet. So, concurrent lines are 3 or more lines. Are 3 or more lines that intersect at the same point. The point of concurrency is where 3 or more lines meet. So we have these different points of concurrency we learned, and this is going to be a chart to help us remember and differentiate, even organize the 4 points of concurrency we had. We had circumcenter in 5-1, incenter in 5-2, centroid in 5-3, and orthocenter in 5-3 as well. So to kind of keep those organized, this one was 5-1. That was like 5.1, 5.2, 5.3, and this was also 5.3. Because in 5.4 we had mid-segments, and there's no point of concurrency with the mid-segments. They don't all meet in the same spot.
Oh, that color makes my eyeballs burn.
Okay. So, our definition is, this is what we say, this is the point of concurrency of what? What do we have 3 of that's meeting to form it? So what do we have 3 of that needs to form the circumcenter?
Vertexes. Dang it. Points.
There's certain kind of lines. Perpendicular lines. Go look. Get out your notes if you need. Get out your notes, okay? Get out your notes if you need. 5.1 notes. 3 is something. What did we talk about in 5.1? Perpendicular bisectors. Yeah, but it was in this huge crowd of everything, and I'm like, sorry. Okay. The in-center is where what meet? Not the perpendicular bisectors, the next one. Angle bisectors.
Isn't there one where the vertexes meet? Just keep
The vertices.
whatever.
Because they're just vertices. There are things that are equidistant from them. Yeah.
Equidistant is the stupidest word I've ever heard in my life.
The centroid is where 3 what come together?
Points.
The centroid is where 3 of what come together? Look in your 5.3. They are a type of segment. Look in your 5.3 notes. No, it's midpoints that go to the opposite vertex. What's the midpoint to the opposite vertex called?
A median.
Median.
Oh,
Oh, sorry, I didn't hear you.
What
The
is
point
it?
of concurrency of the
Is that an angle
median.
bisector?
Yes, angle bisector.
Really? How do you spell bisector?
I don't even know.
Well, we'll draw them down here.
And then the orthocenter is
Medians is plural.
Altitude.
Orthocenter is where 3 altitudes meet. Ooh, had that one.
That'd be a nice outfit.
That'd be a nice little cheat sheet. Apostle, I
Yes.
would not complain for 2 days about dad jokes.
Mr. Castle,
Distance.
How was that not?
What?
Brantley's birthday is on Wednesday, so you know, it should be like a birthday present.
Probably not.
Yeah,
So-
I think it's a test.
Okay, so just Riley can use it then since it's only her birthday.
Mine's on Thursday though. Like,
But yours is on Thursday, yours is on Wednesday, so you know.
Mine is on a Wednesday.
Yeah. So, distance. Guys, voice back off. Circumcenter is equidistant from what of a triangle?
The center. Middle.
No, don't just shout, please. The circumcenter is equidistant from something of a triangle.
The bisector, the right angle. I'm confused because that's what I
Look
thought
in
it
your
was.
5.1 notes.
That's what I thought it
In your
was.
5.1 notes, there's a theorem, a circumcenter theorem, that tells us equidistant from the points of the triangle. What do we call the points of the triangle? Vertices.
That's where they came from.
He keeps saying that. I'm thinking in my head.
In-center is equidistant from the what of a triangle? Not midpoints.
I have a question. Why don't we just go down one and then
going all over though. We're going left to right of these.
I know, but wouldn't it just be helpful if we all just go in a circumcenter and do that one, and then center, do that one?
It works differently for different people. Some people yes, some people no. In-center is equidistant from the, not the vertices, the sides. And we measure that side, the measure at the perpendicular. Okay, so it's equidistant to the sides. Now the centroid is not equidistant from anything. The centroid is where we have a different rule. Anybody remember kind of what that one was?
Let's do.
That was in the center.
Right, angle.
I'm very confused. And I've been confused. I expect all of it. All of it. I need all of it repeated back to me.
2/3 of the distance.
Okay, so the centroid is where we have the 1/3, 2/3 rule. The centroid was our 1/3, 2/3 rule. So I'm going to write that in here. 1/3, 2/3 rule.
Oh, I didn't even see what those numbers said.
Yeah, you can't really read those numbers on there. It's pretty small. So in this triangle, this top part could be 2/3 would be 2/3 of it, and this bottom part would be 1/3 of the median. We don't have anything for distances with the altitude. With the orthocenter, nothing with the distances for the orthocenters.
Oh my gosh.
Location. We're going to do all three locations, and then we're going to move on to the next all three locations. A circumcenter. For an acute triangle, where is the circumcenter? Inside, on, or outside? It's inside, so it's in the triangle. Where is it at if it's a right triangle for a circumcenter? On it.
Oh, it's that. Oh my gosh.
Where is it at if it's obtuse?
Outside.
Outside. This is why we're doing it. Okay. For the in-center, where is it at if it's an acute triangle? Inside. What about a right triangle with the in-center? It's still inside. Remember, in-center, we can think that one's always going to be inside. So if it's
In the
obtuse,
center.
it's also going to be inside. Very good, Aubrey. The centroid. Acute triangle will be where from the triangle? An acute triangle will have the centroid where? A right triangle? Going to be inside.
That's what I said.
As a straight. Oh, yeah.
You looked at me and took
Yeah, it was a full turn versus a half turn of the watch. Okay. If it's obtuse, it's still
inside.
inside.
Inside, inside. I feel. What if you could like take your eraser and like switch the setting?
Okay. So for orthocenter,
Okay. Down.
orthocenter, if it's acute, where is the orthocenter at? What about the right triangle? On.
What the heck? I don't understand any of this. If it's on the center, then why wouldn't it be in the center?
It forms a pattern.
Hey, do we kind of see a pattern here?
No.
Yeah.
One, two,
The ones on the inside are
Circumcenter is like
If it's
Centers
acute,
are like,
three to nine.
other ones are like.
okay, if it's acute, where is it always going to be? Inside, always. If it's right or obtuse, that's where we have the differences. But acute's always going to be inside.
Yeah, because it says center. And if it's outside of the triangle, it's not in the center. All right, Aubrey.
Oh, the spirit. A picture of the type of line. So the type of line, these were perpendicular bisectors. So we need to draw a perpendicular bisector. So I'm just going to draw a triangle. I'm just going to make sure it's an obtuse one, or as this obtuse angle, or close to, or at least, scalene, where all three sides are different. So if it's going to be a perpendicular bisector, let's say a perpendicular bisector to this bottom line. Let me draw it in a different color here. So we're going to be bisecting it at a perpendicular angle. Now, does it necessarily have to go? Can you guys see that gray? Let you guys see this better? So it's perpendicular and bisects it. It doesn't have to go through the vertex, but it could. It doesn't have to, but it could. The most important part is that it's perpendicular to a side and it bisects that side, cutting it in half. Okay, so just make it approximately half. Mine's not perfect.
Mine's not
Make it
even.
approximately. Now this one, for the angle bisector, we're just gonna draw about the same type of triangle here. That was a really rough bottom side there. Oh, much better.
Oh, wow.
Okay. So an angle bisector, that's gonna be bisecting the angle, and it doesn't matter where it goes on the rest of it. It could be perpendicular, it could not be. The important part here is that it bisects this angle. So I'm gonna try and cut this angle in about half and go through there. So I'm guessing it's about there. It's not perfect by any means. About there. And I'm going to show, hey, it's bisected with those arcs. Now this doesn't look like it intersects. It's at a 90-degree angle. And it could bisect the bottom, the side, but we don't know either. The important part is that it bisects the angle.
What are those marks on top?
Those are the arcs to show that the two parts of the angle are congruent to each other. Good question. Because by the time I decided I wanted to have these in here too, and the kind I wanted, I'd already seen them, so. Yep. And then for the next one, I'm just gonna kind of overlay this so we still know the type of triangle we're talking about. So if we have this type of triangle here, this would be a median. Median goes from the vertex, a vertex of the triangle, there's 3 of them, to the opposite side, but this one's at its midpoint. We can try and remember this one because median kind of sounds like medium. And a medium is kind of like the middle size, right? They're usually like small, medium, large. So it's going to go to the middle point. So median goes to the middle point, the midpoint. So you try to think median, medium. It doesn't have to be perpendicular in this one. It looks like it might be. That's a coincidence. And then we have our last one where we have an altitude. An altitude. Altitude goes from the vertex still. So it goes from the vertex, just like a median did. But this one, instead of being at the midpoint, it goes to be at the perpendicular opposite side. And think of this one. When we think of altitude, we think of height, right? Okay, altitude, we can think of height, because that's how we can find the height of the triangle. If you're going to measure the height of something, you want it to be perpendicular to the ground. Okay, if I'm going to measure my height, I don't want to be like tilted like this, right? I'm not perpendicular to the ground right now. You want me to be perpendicular to the ground so you can get an accurate measurement on my height. Just like with anything, you want it to be perpendicular to the ground when you measure for height. So that's what this is. Picture of a point of concurrency. This can get pretty messy, just to be honest. So if I draw about the same type of triangle as we did here, and we try and draw in some perpendicular bisectors, where it bisects the side, it's perpendicular. And I try doing it over here too. Doing over here too. Now my drawing is far from perfect. You guys know that my drawings are always far from perfect, right? Okay, nothing new. They should all meet at one point. In this case, since this is an obtuse triangle, they meet outside the triangle. Based on whatever kind of triangle you drew, it would meet somewhere on it. And it's okay if you're drawing not perfect. This one's going to be probably the roughest of any of our columns is this one. I get that. Give you guys a second with that one before I move on to the next one. next one, just gonna draw the same kind of triangle again. Or at least try to. By drawing my angle bisectors, just bisecting the angle. Close. They should also meet one point, which mine just desperately did not, but I'll just gotta say we did. Yeah. Uh-huh. Nope, those are just whatever. Yeah. This is really just random. Question. Okay, so for this next one, we kind of have it drawn here for us, which is nice. Okay. Three medians, meaning it's vertex, the opposite midpoint. So we should probably draw that these are midpoints. This is the midpoint, and this is the vertex, the opposite midpoint. So we should probably draw those in. Probably draw in these are midpoints, vertex, the opposite midpoint, or median. Medium, size, middle. Then for our orthocenter, when we have three altitudes meet, they all form right angles. So we should probably draw in those right angles if we're form with opposite side. Now the orthocenter, this one happened to be inside because it's in a keyboard. Okay, so significance facts. This one's going to be a pretty important part. Okay, the significance facts is a pretty important part. The significance or fact of the circumcenter is it's the center, what, no way, of a circumscribed Is it a circumscribed? That's the proper word.
No, the entire sentence. Try saying that.
So is the center of a circumscribed circle. Does it make sense that a circumcenter would correlate with a circumscribed circle? Circumscribed is where we take the circumcenter and we draw a circle and it would go around the triangle. That's where it goes around the triangle.
The incenter is going to be the
No.
center of it.
Stop.
What? It's a bendy ruler.
Do not need rulers being broken in this classroom. Do not need this to be in the story. Okay? Not in here.
Mr. Howard's.
Grade and Wydick in 7th grade. I wasn't even there.
I wasn't even there.
But I know about it because it's a story.
My boy got it fun.
It's like
Okay. An incenter. An incenter. This is going to be the center of another kind of circle.
That one is good.
Center of a inscribed circle.
I don't know what any of these were.
That one must mean that
The circle's inside of the triangle.
the circle's
Yeah, thank you. Grammar matters.
I just got 2 free meals at La Fiesta.
Haley.
Oh yeah. Wait. So the circumscribed goes around it.
Ow.
I'll just all of them together.
And then the scribed circle is like inside.
Yeah, it goes inside the circle, so it would touch all these sides. It doesn't touch the vertices, it touches the sides. Okay? The centroid is the balance point of a triangle. It's the balance point of a triangle. Balance point.
Oh, right, because you said if you cut out a triangle and find the beam, you can just balance it.
Yep. If you were to cut out a triangle and you knew its centroid, and it was evenly distributed weight rise like most everything is, so it wasn't like denser in one spot than another or something, you know, you could balance it on a piece of paper, like one of those birds, you know? You see those toys? You could do it like that and balance it there. And it would work.
Okay, so is a triangle called a triangle because tri means three and there's three angles? Science.
Do you just
So, orthocenter. What we need to know for our significance of an orthocenter, okay, we talked about how we're not going to go really into what you do with an orthocenter because it's all calc-based, and we're not going to go into that because this is honors geometry, not calc. So, as for what we need to know about an orthocenter, is that our altitude goes through it. And we know the altitude is the what of a triangle?
It's the where from the line, from the vertex
Okay.
to the
Being
opposite
perpendicular outside.
Yeah.
Yeah, and it shows us the height of it. It shows us the height of a triangle. So what we need to know about the altitude, or about the orthocenter, is that it really just shows us where the altitudes are, which is the height of a triangle. The orthocenter itself isn't the height of a triangle, but it shows us where the height is. It just shows us where the height is, really, is what we need to know. Okay? How tall it is. So this would be the highest point of a triangle versus if you had it here, or here, or here, or here, or here, or here. Question. Alright, questions on this before we move on to a review packet. Now this is a study tool for you guys. This is a study tool for you guys. This is a way that you can have all the information from these 4 different points of concurrency on one piece of paper together, okay? Because if it's in your notes, it's pretty hard to dive through and say, hey, where is all this? As we went through it, you guys didn't know all these off the top of your head, and that's okay. We went through it so that way now it's all in one central location. Just to throw center in one more time. So, I'm going to give out a review, and we have some don't do's. Can I have a volunteer pass these out? Hey, thanks Evan and Gage today. Jacob normally does, so I'll have Evan and Gage do it. Okay, I'm giving you guys each too many. Okay.
Jacob, how do you feel that the drought is over? 90 days since Boston team won the championship.
Oh. The drought is over. It's been so long they've waited.
2013, buddy. When's the last time the Yankees won it?
It's been too long.
Alright. What's off, guys?
5 years.
Don't do 14 through 18. 27 through 32, excuse me. And 43.
Okay, Faith missed it. Faith doesn't know.
Go to number 33 real quick. Go to number 33. I have a note on 33 for us. I have a note on 33 for us, guys. 33. Collectively, y'all. It starts off with number 33, saying segment FG, segment DG, and segment BG, correct? Okay, those should be different ones. What those should be is AG, CG, and EG. So that's what they should be. They should be AG, CG, and EG instead. That's the only note I have. So what we're going to do is I want you guys to work on this. We're going to work on it for the rest of class. Okay? Work on it for the rest of class. And then we'll check it and discuss it tomorrow before we start our test, okay? Or was it, excuse me, this class? Yeah, the Wednesday dates, okay? Questions? Okay, go ahead and begin. You guys may listen to music. And you guys can work in partners. Okay, hey, I encourage you guys to do as much of this without notes as you can. And then think about, and then go through and say, okay, here's what I need to do with notes.